Terraforming Mars. Can we turn the red planet green? For centuries, we have looked up at the night sky and wondered, are we alone? But more recently, a new question has taken over our imaginations. Can we make another world our home? Among the celestial bodies in our solar system, Mars stands out as the leading candidate. It's cold, dry, and barren, but it's not too far and not too toxic. And most importantly, it's familiar. It has seasons, it has ice, it has a day just 40 minutes more than Earth. But here is the million-dollar question. Can we terraforming Mars and turn the red planet green? What is terraforming really? Terraforming is a process of transforming a hostile planetary environment into a one that can support human life, ideally without a spacesuit. The term was coined in 1942 by science fiction writer Jack Williamson, but it didn't really enter scientific discussion until NASA began exploring Mars during 1970s. The goal: increase the temperature, create a breathable atmosphere, melt the ice, and one day plant trees under open sky. Sounds like science fiction, maybe not. Mars has what we need. Mars may be cold and dry, but it has the raw material for terraforming. The polar ice caps and permafrost store enormous amount of CO2 and water, the building blocks of a greenhouse effect. In 1993, Dr. Christopher McKay, a NASA planetary scientist, published a study in Nature suggesting that using Mars' own CO2 to warm the planet could in theory start a runaway greenhouse effect. But it's not easy. Mars' atmosphere is 100 times thinner than Earth's, and it's mostly CO2 already, but not enough to warm it up significantly. According to a 2018 study by NASA and the University of Colorado, even if we vaporize all the CO2 in the polar caps, we would only increase the pressure to 1.2% of Earth's atmosphere, still far too thin to breathe and trap heat. So what do we help Mars along? Nukes, mirrors, and greenhouse gases. Let's get creative and controversial. One idea proposed by Elon Musk is to detonate nuclear bombs over the Martian poles. The heat would vaporize the ice caps, releasing CO2 into the atmosphere. It's fast, dramatic, and very risky. Critics say the effect would be temporary and we would risk making Mars even more radioactive. Another idea: giant orbital mirrors. These massive space-based reflectors would direct sunlight onto the surface, slowly warming targeted regions, no explosion required. A more grounded approach involves pumping synthetic greenhouse gases like perfluorocarbons (PFCs) into the Martian atmosphere. These are thousands of times more effective than CO2 at trapping heat. But there is a catch: producing enough PFCs on Mars would require factories the size of cities, running for hundreds of years. Life finds a way. While engineering Mars' environment might take centuries, we could start small with microbes. Scientists at the University of Arkansas have been studying extremophils, hardy microbes that survive in Earth's most hostile environment: Antarctica, salt flats, volcanic craters. Some of these life forms, like Deinococcus radiodurans or Coccidiosis, can survive high radiation, extreme cold, and low pressure. These could serve as biological pioneers, slowly producing oxygen, altering the soil, and laying the groundwork for future agriculture. In fact, in 2019, scientists from the German Aerospace Center sent the cyanobacteria into the stratosphere, and they survived. This tiny organism could one day be the gardeners of Mars. Terraforming isn't just one project, it's a civilization project. Terraforming Mars isn't like building a colony or a base. It's a planet-wide engineering project, possibly taking hundreds or even thousands of years. It would require thousands of nuclear or fusion-powered facilities, robust magnetic shields to replace Mars' lost magnetosphere, atmospheric factories to build pressure and warmth, and most importantly, patience. But there is a silver lining: we don't have to wait until Mars is fully Earth-like to live there. The first steps would involve terraforming small zones, creating paraterraform domes or eco-bubbles, enclosed cities with Earth-like environments. A proof of concept could be Biosphere 2 in Arizona, a closed ecosystem built in the 90s designed to study self-sustaining habitats. It failed in some ways but taught us invaluable lessons. Mars habitats could start the same way. So why go through all this trouble? For some, it's about survival and backup for humanity in case Earth is no longer safe. For others, it's about curiosity or the challenge of expanding life beyond one planet. And for the dreamers, it's about purpose, about becoming a multi-planetary species. Mars is close, harsh, but not impossible. And with science, creativity, and time, we just might turn the red planet green.